Right, on the vectors question, 2022, paper 1, question 9. So we've got a set of a parallelogram, it says, gives you the two vectors from P to Q and from Q to R. P to Q is 2, 3, minus 4. I like column vectors personally, just a personal preference. Q to R is 5, 0, minus 2. There's no J component there. Because it's a parallelogram, P to S is the same as Q to R, and S to R is the same as P to Q. And we've got to show that it's a rhombus. Now, it's because it's a parallelogram, the opposite sides are equal. We've just got to show that all the sides are equal for it to be a rhombus. So we need to find the length of P to Q and show that it's equal to Q to R. The length of P to Q, so you square the components and add them together to do the square root. That gives us root 29. Q to R is same thing again, no J component, so it's just 5 squared and minus 2 squared. That also gives us root 29, so they're the same length. Make sure you write down at the end that so it is a rhombus, because they'll want to see that. Then the exact area it wants, if I draw a rectangle around it and then break it up like this, you should be able to see that the rhombus is half the area of that rectangle, that dotted line rectangle, because each little triangle is half the little rectangles. So I can find the length of Q to S and P to R. That'll be double the area of the rhombus. P to R, well, as a vector, I can do P to Q plus Q to R will give me the vector from P to R. At the I components, I get 7. At the J's, well, it's just the 3. And the K components is minus 6. And also, I want the Q to S vector. Now, for this one, I need to go from Q to P and then P to S. So minus P to Q is the same as going from Q to P. So I'm doing minus 2, minus 3, and plus 4 added to 5 and the minus 2. That gives me 3, minus 3, 2. So the area is going to be half those two multiplied together, the length of those two vectors. Half of P to R multiplied by Q to S. The length of P to R, square them and together, I get root 94. Square these, add them together, do the square root. I get root 22. So the length of P to R is root 94. Q to S is root 22. When I multiply those together and halve it, I get the exact answer is root 517. Could do it a different way with a bit of trigonometry. I know the lengths of P to Q and P to S, they're root 29. I've just worked out the length from Q to S, that was root 22. So I can use the cosine rule on this to find out this angle. Root 22 squared, root 29 squared, root 29 squared minus 2 times root 29 times root 29 cos of that angle. A squared, B squared plus C squared minus 2BC cos A, if I call that angle A, and that's the side A. Rearranging that, I get the cos of SPQ is 18 over 29. You actually end up with 36 over 58, which is 18 over 29. Now, I want an exact answer because I need the sine of theta, the sine of that angle, not the cosine, to work out the area. I can use cos squared plus sine squared equals 1 to work out the exact value of sine theta. And I get, so if I just do that squared, 1 take away that squared and square root the answer, I get root 517 over 29. You could do it on my calculator actually. If you put this in your calculator, it gives you this as a decimal. But you can sort of trick the calculator, because if you square that, it'll give you sort of that squared as a fraction, as a whole, as an exact fraction. If you square root that answer, it does give you 517 over 29. But I think for the marks in the exam, they're going to want to see you using this. And then And so the area, then I've got two triangles, same area, and each one is a half times the length of the two sides times by the sine of the angle between them. Sine of the angle between them is 517 over 29. Twos will cancel. Those root 29s cancel with the 29. Give me an answer of 517. And there we go.